Okay, I'm sorry about all the confusion. I've been spending the morning trying to figure out what AP is doing. I'm clear on what's on the attest. I've checked with a number of other teachers. So, a second unit that we're going to do is we're skipping to nine, section 9.4. It is primarily focused on ratio test. Um, the key topic here is radius of convergence. It is going to be half of the length of the convergence interval, and I'll explain that when we get to the second example. We're going to start off with reviewing geometric series, and what you see on your paper there here, this part. This is just a review of what we already know. You have a series, written as a series, that could be written as a function here. And the convergence interval is here. And that's where we're going to get this radius of convergence. So I'm going to start with the example, page 51, example 8. It gives you the series n equals 0 to infinity of x plus 5 to the n. The question here is, does it converge or diverge, and on what interval does it converge? This has a variable in it, x, which means this function can converge or diverge depending on what the x is, and we need that interval for which it converges. First thing I like to do is I like to note that this has got a power of on it, power of n. That's where the n is, and it kind of gives me an indication it's geometric. It could also be a ratio test, but you'll know right away. If it's not geometric, then the second thing you do is you try ratio test. So the first thing I'm going to do is I'm going to go ahead and expand it out just so I can see it. So I'm going to plug in 0 for n, and I get 1. I plug in 1, I get x plus 5. I plug in 2, I get x plus 5 square, etc. I can see my first term is 1, so a is 1. And each time I'm multiplying by the same thing, x plus 5. So I see that it's geometric. Once I establish it's geometric, I can write the function for it. The function for it would be 1a over 1 minus x plus 5. So this series equals this, which will come out to be 1 over, quickly to see, negative x minus 4. And you can take out that negative if you'd like to, but what we're learning here today is not how to necessarily write it as a function, but rather find the interval of convergence. Interval of convergence would be, has to be between, the r has to be between these two numbers. Another way to write this, by the way, is the absolute value of r has to be less than 1. This is kind of the notation you use when you're defining it. However, when we're actually finding the radius of convergence, I use this. My r in this case is x plus 5, which tells me that by subtracting 5, my interval of convergence is x has to be between negative 6 and negative 4. That's my interval of convergence. Now, if I think of a number line, these numbers are 2 apart. So the thing we're learning today is, one thing we're learning today is called the radius of convergence. The radius of convergence is, think of the radius of a circle. A radius is half of the diameter. Consider your convergence interval to be your diameter. There's a total of 2 units there's a total of 2 units here between it. So my radius of convergence is 1 because it's half of my interval of convergence. So there's a distance of 2. My center is -5, meaning I have a radius of 1 on each side. So radius of convergence. We'll see that again here in a second. The second example is going to tie into the ratio test. Here is the ratio test. Now, those people that picked up copies of all these, all the flashcards, etc., have this already. The ratio test is used when it's not quite a geometric series. The ratio test allows us to create an R, an arbitrary R, like magic here. I've got an R, and to pause it, make sure you have this written down if you can't find your copy of the flashcards. Okay, the example I'm going to do is from page 511, number 10. And it gives me the series n equals 1 to infinity of 3x minus 2 to the n. Now, if it was just this, I would be thinking that's geometric, and if you write it out, it would be. But this one's slightly different. It's got this thing that messes it up a little bit. This little n at the bottom. That n at the bottom gives me a hint it's probably not geometric, and it won't be. If I write this out, you'll see it's not geometric. I can write it out for you here real quick. It's plug in 1, you get 3x minus 2 over 1 plus 3x minus 2 square over 2 plus ... Now, if I keep writing these out, you'll see that each time I've got this problem, this bottom piece, it won't allow me to find an R. So there's no R. Therefore, not geometric. But it very much looks like it because of this power here. So what I'm going to do is I'm going to try a ratio test. The ratio test, I can find that paper again. The ratio test says to take the n plus 1 term and divide by the a sub n term. So basically what I'm going to do is rewrite this a sub n term, this term right here. I'm going to write it with an n plus 1 in it. Okay, so I'm going to take the limit as n approaches infinity, because this is what you do for a ratio test. And you take the a sub n plus 1 term divided by the a sub n term. You'll get in a habit of writing this in a different way in a second. Let me show you. So I'm going to just write this up. So it's 3, oops, gotta leave myself more space. So 3x minus 2 to the n plus 1 over n plus 1 all over the a sub n term. 3x minus 2 n over n. Now, I don't like the way this is written. I usually don't write it this way when I'm doing the problem. Instead, because every time I'm going to wind up with divide by a fraction. Instead of divide by the fraction, I'll multiply it by the reciprocal right away. And I'm going to separate things so I can clearly define things. So, limit n approaches infinity of 3x minus 2 n plus 1 over n plus 1. This is classically how I would write it right away, because that's how it winds up working. Over 3x minus 2 to the n. Then I'm going to move things around, because I can see this piece and this piece have exactly the same base and they have exponents on them. So limit as n approaches infinity of n over n plus 1. See how I have this separated? And if I take the limit of this, I'm going to get 1 times 3x minus 2 to the n plus 1 over 3x minus 2 to the n, which means I have the following. Now when you have the same base, you subtract exponents. N plus 1 subtract n is just 3x minus 2. Once I get to this point, and this happens right here, I know I've picked the right test. The ratio test is going to yield something productive for me. This essentially, by the way, is going to be my R. If I take the limit as n approaches infinity, I get L'Hopital's rule. I get infinity over infinity here, which means it's equal to 1. You can also consider it's infinity over infinity, so you can consider lead terms. That gives me 1. So this limit goes to 1. So this equals 3x minus 2. That is my magic R. It's not geometric, but it is my R. Now that I have the R, I can find the radius of convergence. Because the R has to fall in between. Add 2. Divide by 3.
Hey!
Yeah, that's my magic phone. And there is my interval of convergence. Now, to do radius of convergence, what I'm going to do is I'm going to consider the length between here and here, and if I do that, the length is 2/3. So consider that my diameter, if you want to say it that way. It's my diameter is 2/3. The distance between 1 and 1/3 is 2/3. Therefore, my radius is half of that, which is 1/3. Now, the next thing I'm going to show you, I don't know if it's directly tested, but certainly it's a skill that you want to have if they're asking the question converge or diverge. It's called the nth test. Again, this is on your flashcard item. You can see that right there. Actually, the nth test, if I can't recognize something as geometric, or I don't feel like it, if I don't feel like it could be a ratio test, I certainly want to do this nth test. The nth test is only good to show something is divergent, but if I can do the nth test real quick and determine something's divergent, then I don't have to try to find an interval of convergence. It saves a lot of time, and it's pretty quick, easy test. Basically, it says it will diverge if the limit of the a sub n term does not equal 0. It can't tell me convergence. It can only tell me if it diverges. If this test does not pass, then it's not divergent. I have to try a different test to make this work. I'm going to try page 511, number 30. It gives me this one. See right there, that part right there, I would feel that's geometric, but then they go this n plus 1. Now, some people are going to go right for a ratio test. That's great and all, However, I suggest to you that let's eliminate the possibility of divergencies right away. So what I'm going to do is I'm going to do the nth test on this puppy. So I'm going to take the limit as n approaches infinity of 2 to the n plus 1. Pii, infinity over infinity. L'Hopital's rule applies. So this equals the limit as n approaches infinity of, now I take the derivative of the top, derivative of a to the u is a to the u times ln 2 times 1 over 1. Now if I take the limit, I plug it in, I get 2 to the infinity times ln 2. Well, that's infinity. Ta-da! Done. If I wanted to confirm this, I mean, if I wanted to show you this and you don't buy this, the other choice is if you had chosen to go right to ratio test, it requires a little bit more work. But I will show you the same conclusion will occur if I do the ratio test. So I'm going to take exactly the same series, and suppose I choose the ratio test instead. I have this. And I'm going to choose the ratio test. Because I know it's not geometric. I could write it out and show you it's not geometric. Ratio test says take the limit as n approaches infinity of 2 to the n over, 2 to the n plus 1 over n plus 1 plus 1. Remember, I'm taking and I'm adding 1 to the n. So I added in to 1, n plus 1 here and here. Then over the nth term, which is this. And you can see why I don't like to write it this way. Ratio test, I usually write it as times the reciprocal right away. It's less messy. So the limit as n approaches infinity of 2 to the n plus 1 over n plus 2. I went ahead and fixed that one. Times reciprocal n plus 1 over 2 to the n. Now I'm going to get these two guys with like bases together. And I'm going to put these things, I really consider those the coefficient, n plus 1 over n plus 2 times 2n plus 1 over 2 to the n. Reducing that, I get n plus 1 over n plus 2. I'm already taking the limit in my head. This is going to be 1 times, same base, subtract exponents. N plus 1 take away n is 2. Now remember, this is creating a fake r, like a g. I think I have an r. The r here, you take the limit of this part, I get infinity over infinity. L'Hopital's rule applies. Lead terms, however you want to look at it, it's 1. So this is 1 times 2 is 2. Now, the ratio test, in fact, here definitely shows that, in fact, it is not convergent. Why? Because the interval of convergence for these functions is this. Does 2 fall in that? No. Since it doesn't fall in the interval of convergence, therefore, it diverges. So either way you did it, I like the nth test right away sometimes if I'm not sure what else to do, because the nth test can allow me to determine it's divergent quickly and efficiently. Now this last thing is called direct comparison test. If they test you on this, I'll be surprised, but I'm going to show it to you anyway. has a lot of neat little things about it that I want to show you. Basically, if you don't have it written down, hopefully that's why I have this here. You can copy this down real quick. It's comparison. I mean, that's exactly what this is I'm going to compare. I'm going to take a function they give me and compare to one that is similar. Let me give you a graphic description of that. If I have a function that they ask me about that I know nothing about, and I say, well, it compares to this function. It's very much like this function. So here's the function I'm comparing it to. I'm going to call it the CN function. I know this guy. Let's suppose because it comes down here and it's approaching that 0, I'm going to say, hey, that one definitely will converge. Well, if the function they ask me about, which is a sub n, is below it, it's trapped below a convergence, which means it has to also converge because it's below. So basically, if I can find that the Cn is bigger than the An, then I can state for sure that if this one converges, this one must also converge. So they're going to give me this one, and I'm going to find a comparison function or a comparison nth term that allows me to converge it. Now, conversely, hypothetically, if I find a Cn here and my An is above it, this one converges, that tells me nothing about this one because I don't know where this guy's going, but I know it's above the convergence space. The convergence space is down here. Now, also there's the divergence piece. If I can find a comparison function and it's going like this, it's diverging. I don't want the a sub n term to be down here because it's now trapped in between the convergence piece here. I don't know what it does. I want the a sub n to be here. I want a sub n to be greater than Cn. If I can get that, if I can find a comparison function where it's below it and this guy diverges, then this one's above, therefore it must also diverge. So we're kind of trapping these things, and we're going to trap a function. And when I show you this example, you'll see why it's so easy to determine a comparison. Oh, by the way, you will be interrupted. You're at my house, and my wife and my dog are coming back from their walk. The example I'm going to do is page 511, number 33. They give you the series n equals 1 to infinity of 2 sub n over 3 sub n plus 1. This piece right here really gets me, the plus 1. That tells me that I will probably be doing a direct comparison. I really wish this thing was 2 to the n over 3 to the n. Why? Because this can be written as 2/3 to the n, and if I write this out, I would show it's geometric. Not only if I write this out, and I could do that, let's write that out real quick. N was equal to 1, so I've got 2/3 plus 2/3 square. Do you see the r is 2/3 and 2/3 is between -1 and 1? This is going to play into the whole thing of comparison. This puppy right here is geometric. This one compares to this one. So what I have to do is I have to first state that 2 sub n over 3 sub n plus 1 is actually smaller than 2 sub n over 3 sub n. Keep in mind, think about this. If I add a 1 at the bottom, I'm dividing by a bigger number. This is bigger than this. Since this one's bigger, that makes the value of the whole term smaller. So by adding 1, I make a smaller function. If I had subtracted 1, I'd make a bigger function. Okay? So I pretty much have completed this. I just need to formally write this out. First thing is you say this. Hey, look, I have a Cn that's less than, an an. This is my actual function. That's my an. Comparative function would be Cn. I have this is true. This is a given statement. Since a sub n is less than Cn, it's trapped, a sub n is trapped below this guy. Since it's trapped below and Cn converges, which I just showed you here. I have an R that's 2/3. It's geometric. Cn is geometric and converges. Since I already had this, since this is smaller, and see by direct comparison, don't worry, there's actually this thing called indirect comparison or limited comparison test. We're not going to do that one. Direct comparison, an converges. So let's walk through this real quick. This is the original function they gave me. This is my a sub n. I saw the plus 1. I also saw when I wrote this out, it's not geometric. I also could try the nth test. The nth test won't work either. So that leaves me stuck and trapped with the, let's go with a comparison. I saw the plus 1, that was a tip off. This becomes my comparison function. I showed that the comparison function is bigger than the function, the series they want. And since that's true, and I found that the Cn converges, therefore by the convergence, the other one converges. And that's pretty much it for today. Please be on the video conference at Google Meet tomorrow so we can talk through some things. I want to relieve some of your anxiety. I had pretty much everything settled in my head until AP threw some wrinkles in it. But it's not going to affect this at all. I was right to begin with. So see you tomorrow.